All right, so we are on half angle identities today. So our learning target is I can use the half angle identities to find the half angle values. So we have this question again, does the sine of 30 equals 1/2 times the sine of 60? So let's go ahead and see if we can find the sine of 30, and let's see if we've got the 1/2 times the sine of 60, and then see if those two equal each other or not. So once again, we have to check on the unit circle, our values. So here's 0 degrees, 90 degrees, here's about 30 degrees, and here's about 60 degrees. So at 30 degrees there, we have the ordered pair there, the square root of 3 over 2, 1/2. At 60 degrees, we have 1/2 square root of 3 over 2. All right, so the sine of 30 degrees. So at 30 degrees, the sine corresponds to the y value at 30 degrees, which is 1/2. At the sine of 60 there, the sine there corresponds to the y value at 60 degrees, which is the square root of 3 over 2. So we get the square root of 3 over 4. And so does 1/2 equal, I'll write this down, 1/2, does it equal the square root of 3 over 4? No, those are not equal to each other. So this is definitely a no. You're going to see as we go with these formulas up here that the sine of 30 degrees is equal to the sine of 60 divided by 2. That is half angle. So we have some half angle formulas here. The sine of theta divided by 2 is equal to plus or minus the square root of 1 minus cosine theta all over 2. And then we got the cosine of theta over 2, and you can see its formula. The tangent of theta divided by 2 has 3 different formulas there. And again, it has that sine of theta over 2 divided by the cosine of theta over 2. And it has 2 other formulas there as well. So again, you can either copy those down or use it from the unit form for identity sheet. So we are going to solve some problems here. We've got the cosine of x is equal to 5/13, and we're supposed to find the sine of x. So yeah, let's use our cosine squared x plus our sine squared x equals 1 formula to find the sine of x. So this is 5/13 squared. That gives us 25 over 169. Let's subtract that fraction there from both sides. We need to get a common denominator. The common denominator is 169. So we get sine squared x equals 149 over 169. We need to get the sine of x, not the sine squared of x, so let's take the square root. So we get sine x equals plus or minus 12 over 13. So again, we have to figure out the sine of our value. So up here it says x is in the first quadrant. So if we look in the first quadrant, both your x value and your y value, or your cosine and your sine there, are both positive. So we have to find the positive value. So the sine of x there is 12/13. So we've got the cosine is equal to 5/13, and we're supposed to find the cosine of x divided by 2. That's the half angle. So let's go ahead and use the half angle formula. So we know what the cosine of x there is. So let's plug it in there. It's 5/13. We need to get a common denominator. A common denominator here is going to be 13. So 13 plus 5 there is 18/13 divided by 2. Let's change that into a multiplication problem so it becomes 18/13 times the reciprocal. of 2 over 1, which is 1 over 2. Multiply our numerators, multiply our denominators. I'm going to reduce that down. All right, so then the square root of 9 up there is 3. Cannot find the square root of 13. So I'm going to multiply my numerator and denominator by a square root of 13 since we don't want to leave our answer with the square root down the denominator. So we get 3 square root of 13 over 13. And so now we have to figure out the sign of our value here. So something you need to know here. So I'm going to draw out a unit circle here again. We're over here in quadrant 1. If you think about any quadrant 1 angle over here, so let's say you take 60 degrees over here, that's in quadrant 1 here, and you divide that by 2, you get 30 degrees. Any angle that's in quadrant 1 there, and you take it and you divide it by 2, your angle is still going to be in quadrant 1, so your value there is going to be positive. So our solution there is 3 square root of 13 over 13. This is the one where you're going to, for half angle, you're going to have to figure out which quadrant it's in. So I'm going to give you a hint here. If you're in quadrant 1 or you're in quadrant 2, your half angle is going to end up there be in quadrant 1. All right. If you're in quadrant 3 or quadrant 4 originally for your angle, your theta divided by 2 there is going to be in quadrant 2. All right. So for instance, over here, if I'm in quadrant 2 over here, and let's say I have like 160 degree angle over here, and I divide that by 2, I'm going to end up being over here in quadrant 1, and I'm going to have an 80 degree angle. So whether you're in quadrant 1 or quadrant 2, your half angle is always going to be in quadrant 1. So therefore, you're always going to have a positive and a positive for both sines and cosine. All right. So then what about quadrant 3 and quadrant 4? Let's do those in different colors. So here's quadrant 3 and here's quadrant 4. If you pick an angle down here, so let's just say, I don't know, 200 degrees, and you divide that by 2, so let's say theta is equal to 200, well then 200 divided by 2 there is 100. And that puts you up there in quadrant 2. So that's why I'm saying quadrant 3 puts you in quadrant 2. So now let's look at a quadrant 3 angle. So let's pick something like 300 degrees. All right, so 300 degrees, if you take that and you divide by 2, so theta divided by 2 there, 300 divided by 2 there is 150 degrees, and that's up there in quadrant 2. So whether you pick an angle in quadrant 3 or in quadrant 4, they're always going to put the half angle there in quadrant 2. And in quadrant 2, remember your ordered pairs go negative and then positive. So your cosine, depending upon if the original one is quadrant 1 or quadrant 2, your cosine is going to be positive. If the original angle is in quadrant 3 or in quadrant 4, then your half angle is going to be in quadrant 2, and your cosine there is going to be negative. All right. But sine, it doesn't matter which of the 4 there, which quadrant you are in. Notice the sign there, your y values are always positives. So you might want to write that down someplace. It might be important. All right. So going on to what about the half angle there for sine? So in this case, the half angle there for sine, we can find that. We can just use our nice formula there. It is plus or minus the square root of 1 minus cosine x. Again, make sure you're using the formula that's being given there on the Unit 4 identity sheet. And so it's plus or minus the square root of 1 minus 5/13 divided by 2. Again, get that common denominator. Our common denominator is going to be 13. So we get 13 minus 5, there is 8. 13ths divided by 2. So let's go ahead and take 8/13 and multiply by the reciprocal of what's down the denominator, which is 1/2. So we get 8/26. We can reduce that down to 2 goes in 8 there 4, 2 goes into 26 there 13 times. So square root of 4 is 2. Cannot find the square root of 13. I'm going to have to multiply my numerator and denominator here by a square root of 13 because you cannot leave a square root in your answer. So you get 2 square root of 13 over 13. And it's plus or minus. So since we're in quadrant 1, the half angle, remember, a half angle is going to stay there in quadrant 1. So you're going to take the positive value. 2 square root of 13 over 13 is our solution there. You only have to worry about this for half angles. All right, what about tangent? Tangent. So tangent is the easiest one to do in this case. It's up to you which one you want to do. We could do, since we're doing tangent of x over 2, you could do the sine of x over 2 divided by the cosine of x over 2, since we found those. We could also do 1 minus cosine x divided by the sine of x, which is the one I'm going to use for now. So that's 1 minus 5/13 over 12/13. I'm going to need to get a common denominator, which is 13. So I get 8/13 divided by 12/13. 8/13 times the reciprocal. So 13s can cross out. We get 8/12. Reduce both of those down by 4, and we get 2/3. Notice there wasn't a plus or minus in front of this answer, any of these answers here, so it's not like we have to figure out the sign. It just automatically comes out to be positive 2/3. So there's a U-turn problem here, a your turn problem here. So go ahead and see if you can do that one. So pause the video right now and then start it up again. All right, so example 2, the sine of x there is equal to negative 2 squared 6 over 5. It's in the third quadrant. We're supposed to find the cosine of x. So again, we're going to use sine squared x plus cosine squared x equals 1 to find cosine x. So negative 2 square root of 6 over 5 squared. So if I square both of these terms up here, negative 2 squared, there's 4. Square root of 6 squared is 6. 5 squared there is 25. That's 24/25. I'm going to subtract 24/25 from both sides. I'm going to get a common denominator, which is 25. Okay, so now solving for cosine. So I'm getting the cosine of x. The square root of 1 is 1. The square root of 25 is 5. It says x is in the third quadrant. So this is just regular. It's not half angle. So this is the third quadrant. What are the signs down here? Your cosine is negative and your sine is negative. So we have to pick the negative. So our cosine of x there is negative 1/5. All right, so now we're supposed to find the half angle. So the half angle here, keeping in mind here, because our half angle formula involves cosine, we just found out that the cosine of x there is equal to negative 1/5. Okay, we just found that from the last one. So the half angle formula here is plus or minus the square root of 1 plus the cosine of x divided by 2. So that's plus or minus 1 plus negative 1/5 divided by 2. I'm going to have to get a common denominator. Common denominator is going to be 5. So 5 plus a -1 there is 4/5 divided by 2. So 4/5 divided by 2 is the same thing as timesing by the reciprocal of 2, which is 1/2. So we get 4/10. So I'm going to go ahead and reduce this down. I get 2/5. Cannot leave a square root down here in the denominator, so I'm going to multiply the numerator and denominator by square root of 5. So I end up there getting the square root of 10/5. All right, so remember, we're in the third quadrant, and we said that if our original angle is down here in the third quadrant, then our half angle is going to be put up here into quadrant 2, right? And then our ordered pair up here goes negative and then a positive. So since this has to be the negative, so it's negative square root of 10/5. Again, if the original angle, which is theta, is in quadrant 1, then the half angle is going to be in quadrant 1. If the original angle is in quadrant 2, the half angle is going to be in quadrant 1. If the original angle is in quadrant 3, then the half angle is going to be in quadrant 2. And if the original angle is in quadrant 4, then the half angle there is going to be in quadrant 2. All right, so now we're supposed to find the half angle of x/2. And again, bear in mind, the formula involves cosine, and we already found the cosine of x. It's equal to -1/5. So let's use our formula. It's plus or minus the square root of 1 minus cosine x divided by 2. So a minus minus is going to give us a plus. And we're going to also have to get a common denominator of 5. So 5 plus 1, there's 6/5. Change it into a multiplication problem. So we got to flip that second fraction. So then we end up here at plus or minus 6/10. Reduce that down, 2 goes into those. So that's really plus or minus the square root of 3 over the square root of 5. Cannot leave a square root of 5 down in my denominator, so I'm going to have to multiply the numerator and denominator by the square root of 5. So I get the square root of 15/5. Since our original angle there was in quadrant 3 for sine, that puts us in the second quadrant then. So we were down here in quadrant 3 with our original angle. So now we're up here in quadrant 2 with our half angle. And in quadrant 2, our ordered pair is a minus and then a plus. So our sine is a positive. So we end up there with the square root of 15/5. All right. So we're supposed to simplify these using the half angle formula. So we do not know what the sine of 22.5 is. But is there an angle usually over here in the first quadrant here? So you got 45, 60, and 30 degrees. There are 2 of those that maybe one of those, since we're doing half angle, one of those that we can divide by 2, and it'll give us 22.5. Oh yeah, 45. So if I take the sine of 45 degrees and divide it by 2, I'm going to get 22.5 degrees. All right, so then I can use my half angle formula. So remember how this goes. This is like this 45 here is your theta or your x. So then the formula here says, well, we'll do this, plus or minus the square root of 1 minus cosine of 45 divided by 2. So then 45 degrees over here, the ordered pair is the square root of 2 over 2 and the square root of 2 over 2. So sine or cosine there is our x value. So that's a square root of 2 over 2. So we get plus or minus 1 minus square root of 2 over 2 divided by 2. So let's get a common denominator of 2 and put it together as one fraction. So you get plus or minus 2 minus the square root of 2 over 2, and then the whole thing is still divided by 2. All right, so keep writing this out. You get 2 minus the square root of 2 over 2, and then times the reciprocal, which would be 1/2. And so that's plus or minus. So multiply your numerators, multiply your denominator, we get 2 minus the square root of 2 over 4. And so up here in the numerator, I get the square root of 2 minus the square root of 2. Down here in the denominator, square root of 4, there is 2. So then we have to decide the sign. So since it was a sine of 22.5, which is in quadrant 1 there, or you can look at 45. 45 was in quadrant 1. You took the half angle of it. It's going to still be in quadrant 1, so it's a positive value. So 2 minus the square root of 2 over 2, positive value. So tangent there. Let's do the tangent. So the tangent is 45 degrees divided by 2. And then using one of the formulas there, I'm just going to use 1 minus cosine 45 divided by the sine of 45. Well, we know what the cosine of 45 there is. It's the x value at 45 degrees with the square root of 2 over 2. And the sine of 45 degrees there is also square root of 2 over 2. This is the y value. We're going to get a common denominator. So we get 2 minus the square root of 2 over 2 divided by the square root of 2 over 2. So let's change that into a multiplication problem. So I have to write the reciprocal now. So then these cross out. And we get 2 minus the square root of 2 over the square root of 2. But we can't leave a square root of 2 down in here in the denominator, so I'm going to multiply both the numerator and denominator here by the square root of 2. So then doing so, I can distribute this square root of 2 through, so I get 2 square root of 2 minus square root of 2 times square root of 2 is square root of 4, which is 2. And then down here, square root of 2 times square root of 2 is square root of 4, which is 2. And now I can see up here that this here can be reduced down. So I'm looking at that 2. There's 2 in every single term there. So if I want, I could just say, oh, I'm going to reduce this all down by 2. So I get the square root of 2 minus 1. Or another way you could have looked at that was you could have pulled it apart. I could have done square root of 2 over 2 divided by the common denominator minus 2 over 2. So then these would cross out and you get the square root of 2 minus 1. Again, the sign for tangent just happens to be natural because there's no plus or minus out in front of the original problem. All right, so our learning target, I can use the half angle identities to find the half angle values.